welcome you all back to this course on blockchain and its applications. Today, we will talk about some more details about basic cryptographic primitives. So, this is the fourth lecture in this course and the second on the topic of basic cryptographic primitives. In this lecture, we will cover the following concepts. Of course, we are going to continue our discussion on cryptographic hash functions that we started in our last lecture. Specifically, we will have some more details about SHA-256. In the last lecture, we already introduced what a hash function is. We have also mentioned that one of the hash functions that is used in the context of blockchains like say Bitcoin, it is called SHA-256. So, we will have more details about SHA-256 in this lecture. Also, what we will see here is that there are different ways in which we can do hashing of multiple data items, and we will show that the way we proceed from this process of combining two or more data items when we do their hashing. So, that could vary quite a lot, and we will see what its impact is on the final output. And the reason why we do that is that when we use hash functions in the context of blockchains, we will see that we will be making use of those types of hashing in different types of applications. The main keywords that we have for today's lecture are, of course, hash function, secure hash algorithms, and then the patterns of hashing data. So, we will see what these mean as we proceed in this lecture through various slides. So, we are now going to focus on SHA-256, and SHA-256 it is important because it is used in Bitcoin mining, and it is the main idea behind construction of Bitcoin blockchains. SHA of course stands for secure hash algorithms. As we see here, this is important that secure hash algorithm, and it generates 256 bit message digest, which we have mentioned. So, that means that independent of whatever is the input length of the message, the output is always going to be the same, that is of 256. And in our last lecture, we have also seen that how in the web application we have seen, which is the supplementary material for the textbook that was mentioned, that you can give any message as input and you can see the output, and for SHA-256 we have seen that it has 64 hexadecimal digits, which means that it is 256 bits of output as the message digest. And this SHA-256 is part of a family of cryptographic hash functions which were designed by United States National Security Agency or NSA, and they are the organization which specializes in these types of secure primitive development. Let us see a little bit of the steps in creating hashes using SHA-256 for any input message. So, there is a bit of pre-processing that needs to be done, because as you see that we set the overall input message that could be of any arbitrary size. But what we need is that for actually applying the SHA-256 algorithm, we have to make this input message size to be a multiple of 512, that is 512. So, if the length of the message m is L, so if the length of the message m is L and L is of course not a multiple of 512, means L mod 5112 is not 0, then what we do is that we append the bit 1 at the end of the message, and what we do is that append k number of 0 bits, where k is the smallest non-negative solution to the equation L plus 1 plus k is equal to 448 mod 512. Okay. So, this is a very simple step, that in order that the input message size matches with the requirement for applying this SHA-256 algorithm, what we do is that we pre-process it so that we get certain properties to be satisfied, as it's shown here that we have appended the bit 1 at the end of the message, and then we append k number of 0 bits, where k is the smallest non-negative solution to this particular equation, and then append the 64 bit block, which is equal to the number L written in binary. So, it is fairly simple that we make this length divisible by 512 no matter whatever is the input length of the message. And this is very important, because the subsequent steps of the algorithm, they will be applying on this input size of 512 bits. So, first of all, what we said, that the input length could be any arbitrary size for the message. There are two possibilities: less than 512, it could be more than 512, it could be not really a multiple of 512, but more than 512. So, what we are doing by this pre-processing step, we are ensuring that the total length is divisible by 512. And why we are doing it? Then we can partition this message, the complete message with the pre-processing, into a certain number of 512 bit blocks. Okay. So, say the length is now 1024, then we can partition the message into two 512 bit blocks, and we call them as, say, M1 and M2. If there are, say, more such, that there are, instead of 1024, say the length is 2048, in that case what we will do is that we will partition this message into four 512 bit blocks, and we will call them as M1, M2, M3 and M4. So, in general we can have up to n number of such 512 bit blocks, and each such 512 bit block is further divided into 32 bit sub blocks, and we call them as M0I up to M15I. Okay. So, what does it mean? So, we have each block of 512 bit length. Okay. So, if we divide it into 32 bit sub blocks, how many blocks do we get? We get 16 such sub blocks. So, consider that we are dividing this particular 512 bit block Mi. So, this Mi, that represents the ith 512 bit block, and then we have divided that into these 32 bit sub blocks, these 16 32 bit sub blocks, and we number them as Mi0, Mi1 up to Mi15. And what is the purpose of that? Then once we have done this, then we can now apply the SHA-256 algorithm. These message blocks are processed one at a time and start with a fixed initial hash value of H0. So, if you see here, we have this Mi0 up to Mi15, and the original 512 bit blocks were M1, M2 up to Mn. So, we had n such 512 bit blocks. So, what it does is that it chooses a fixed initial hash value, which is H0. Of course, as you can see here, there is no initial hash, we have only these different blocks for the message which was pre-processed, and we got these messages. And now what we are doing is that we are now generating the hash value, and this is done sequentially, as we can see in this particular state or this particular step, that Hi is computed from Hi minus 1, and then we apply this Cmi of Hi minus 1. Now, of course, it means that for H1 I need an H0, right. When I is equal to 1, then what is the value of Hi minus 1? So, that is what is denoted here as H0. So, what we do is that we consider a fixed initial hash value H0, and then we sequentially compute Hi using this particular formula. What is C here? So, C is a SHA-256 compression function, and plus means modulo 2 raised to the power 32 addition, and Hn is the hash of M. So, that means that I first get H1 from H0, as you can see from this relationship, and H0 is fixed as an initial value of the hash. Then from H1 we can get H2, and from H2 we can get H3, and so on, and finally we will get Hn, and which is the hash of M. And what is n? If you remember that n, looking back at our example, that n was the number of 512-bit blocks. So, by doing this, what we have achieved is that by sequentially computing, we will get Hn, and that will be the hash value for the complete message which was given as input, that is of M. So, this is the pictorial representation of this SHA-256 algorithm, and this initial hash value that we said, that is this initialization vector as is shown here on the left of our diagram, and then we have these C values as were mentioned here in our sequential step of computing HIs, and the M0, M1, these are all given as input, and finally what we get as the output is this Hn, which is the hash of M. So, given the M, we finally get the message digest. So, we have so far understood what is the hash function. We also, in our last lecture, we studied what its properties are and why those properties are important in the context, of course, of blockchain, and we will appreciate that as we discuss about the use of hash functions while constructing a blockchain. We have simply so far studied what are its important properties, and we will keep those in mind when we talk about the applications of hashes in creating, that is, in constructing a blockchain. Also, what we have seen is that for blockchains like Bitcoin, SHA-256 algorithm is used, which is one of the most popular hash algorithms, and it generates message digests which are of length 256, and it is computationally really impossible almost, we would say. It is very difficult. It is not, I mean, it is going to take years and years to determine that given any particular value of message digest, what was the original message. Of course, going from the message to the message digest is fairly simple, it is computationally very efficient, but moving back from the message digest to the message, it is infeasible. Now, what we will see is that if there are more than one pieces of data, what are the different ways we could combine their hashes. So, this is what we call as the patterns of hashing data, and we will talk about these 5 different types of combinations or patterns. One is what we call as the independent hashing, second is what we denote as repeated hashing, then combined hashing, sequential hashing, and hierarchical hashing. Of course, you can also think of other ways of combining hashes of data. You are welcome to think about others beyond these 5 different types that we discuss here, and let us see what these mean. And these examples, the diagrams are available in this book that we have referred in our last lecture also, and are also listed in the references in this particular lecture. Say we have these 2 pieces of text, one is hello and the other is world with the exclamation mark. So, we have one of them as hello and the other is world with exclamation mark. Okay. And then what we are saying is that we want to hash these 2 pieces of data. So, in independent hashing, what we do is that from hello we do the hashing and we get the hash. One point to note here is that, of course, if you use SHA-256 algorithm, we will not have only these 8 hexadecimal digits, but these are shown here so that it becomes much more compact in its representation. It is just showing the first 8 hexadecimal digits of the complete 256 hexadecimal digit length of the hash value. Now, similarly for world also we get this as a hash. Again, this is only the first 8 hexadecimal digits. Now, what we mean by these first 8 hexadecimal digits? Let me show that through this example, that as we have seen that in our last lecture, so we saw these hash functions, okay, where if you remember we entered some text and we got the hash values. So, these were the original outputs that we got for different types of hash functions. But if you go to this supplementary material, all the different other types, so there is this simple another hash value calculation, where if I give say hello, and then if we click on calculate hash value, we get these 8 hexadecimal digits, the first 8 hexadecimal digits. This is for ease of representation. So, effectively if you see that if we considered hello here in the original option, where if we had typed in hello, so let me do that for the original one here for hello, and we calculate the hash value. So, we see that the first 8 digits, if we can remember, these are 1, 8, 5, f and so on. And now, instead if we go to this second option, where we again type in hello and then click on calculate hash value. So, you can see that we are having those same first 8 hexadecimal digits. So, we are using this for the sake of brevity, and that is what actually is shown here. For hello, you can see that whatever we got there, those are shown here as the first 8 hexadecimal digits. Similarly, what we can do is that for world with the exclamation mark, if we did it here, of course, we can simply run it here, so that we can see what we get as output, and it is like 514b 6 something, and you can see that the same is shown here as output. So, by independent hashing, what we mean is that for these 2 pieces of input message, we carry out the hashing independently. What about repeated hashing? And this is something which is interesting, that if you remember that for SHA-256, if we do this hashing, so we get the first 8 digits like this. Okay. So, of course, in order to get the full value of the message digest for hello world, so what we can do is that we can go back to this particular option and we can calculate its hash value. And now, here I can select this SHA-256 output for the input of hello world, and then what I could do is that I could come back here and give this as the input, and I could ask it to generate the hash value. We get this as the first 8 digits of the hash value, which is a hash of the hash of hello world. So, that is what we mean here, is that if we try out this repeated hashing. So, on hello world we first apply SHA-256, we get this as the first 8 hexadecimal digits of the hash value, and then if we apply hash on this as taking this as the input, we will get something like this 45a this as the output, and of course, these two are not matching, because if we give this as the input, then only we will get this as the output. So, what we did here is that we gave the entire 256 bit as the 256 bit as the input for this second step, and we got this as the output. So, instead if we ran only the first part of it, so if we get this as a hello world and we take the first eight digits, which if you see here, so this is matching with this 7f and 83b165 like this, and now if I select this and I run this hash on it, and then we get this 45a47, and which you see is matching with this as the output. So, what I had shown was, if we repeatedly ran this hashing using the 256 bit output of the first step, then we would have got that as the result. And as you see that this time I took only the first 8 hexadecimal digits and I run the same process, and I get this as the output, which matches with what was shown in this output from the particular web application. The third type is combined hashing. So, if we are given one input as hello and the other as world with the exclamation, then of course we can first concatenate hello and world, and then we carry out the hashing on it using say SHA-256, we will get this as output, and that exactly is what we have already seen by giving hello world exclamation as the input, and we got the output of which the first 8 hexadecimal digits are what are shown here. The next step that is possible is that, or next type that would be possible is that we first apply hash function on hello, and then we combine this hash with the second message, which is world question mark, I am sorry, world exclamation mark. So, what we need to do is that we first have the output of hello, and then we concatenate that at the end of world exclamation mark. Now, I get a concatenated string and apply the hash on that. So, let us try out whether we have been able to understand what is being mentioned here. So, first of all, what we will give here is that we will give here the input as hello, we generate this as output, and I am copying that, and now what does it say? It says that I have to concatenate this output, and if you see, this output is the same as the output that is shown here on the screen in the figure. So, what we do is that we have this world with exclamation written here, and then I am concatenating that. So, I have pasted this previous output here, and now I have the concatenated total string as the input for this second step of hashing. So, what we do is that now I click on calculate hash value. So, I get something like 5795. So, I got a little different. So, it could be just because that the there was a space in between. So, that would result in this 5795A, and we got something as the output which is a little different. So, this could be just because of the extra space that is included there in the process. So, that is what we mean by sequential hashing. And then finally, what we do is that we take a look at the hierarchical hashing. So, what we do here is that here we first hash hello, we get an output, and then we hash world exclamation independently, and then what we do is that we get back to these two hashes and apply the hashing on that. So, let us try to do that. So, first what we do is that we have this hello, we get this as the output. Okay. So, this is our output, and I am saving it in Notepad, and then I am getting the hash of world with the exclamation mark, and we calculate the hash, and we get that as the output. So, I am saving that here next to the previous hash. So, like we are showing here. So, we have 185F etcetera as the first one, as you can see 185F as the first one, and for the second one it is 514 something, and we can see that also here in the diagram. And then what we do is that we have this entire this string, and we try to apply now this hash on this concatenated string, and we try to calculate the hash value. And so, again we see the different one. So, this is the reason is that we need to ensure that we get the total 256 bit values concatenated, and then we will get the correct output. So, this was only to show that the way that we will be concatenating the output. So, let me also show you what happens if we use the entire 256 bit outputs for each of these. So, let us again try it out with hello, and we calculate the hash value, and I have this 256 bit hash. So, this is actually how it will be done. What I showed was only for those 8 hexadecimal digits. Now, I am showing it for your convenience with the entire 256-bit output of the SHA-256 algorithm. So, what we have done? We have first chosen hello and generated its SHA-256 hash, and I am storing that in this notepad. As you can see, I have stored it here, the 256-bit hash, and then what I do is that I have the second message, which is world, and then for which I calculate the hash value, and now I choose this, select this hash value for world, and then what I do is that I concatenate that next to the previous one, and now I have got this entire concatenated 512-bit string, which is now going to be the input for carrying out the next level of hashing, and for that I paste this as the input, and then I try to calculate the hash value, and we get this as a hash. So, the point that is important here is that this is the full step. The previous one was showing only for those 8 bits, and depending on which way you combine them, whether you are taking the first one first and then the second one, or the second one first and then the first one. So, you can try these out, and you will see that if we do like this, then we will get of course different hash values, and in this last step I have shown you exactly how one would do if one wants to carry out this form of what we have denoted here as hierarchical hashing. Okay. So, I first had calculated the 256-bit hash of hello, then the 256-bit hash of world with exclamation, and I got those as inputs, and you can see that I have this matching first 8 digits of those, and then as we showed here is that we concatenated the entire 256 plus 256, that is the 512-bit concatenated string, and gave that as input for the next step, and when we did that we get this as the output. So, that indeed would be the final output for the hierarchical hashing. Now, why we are talking about all this? The reason is that, as we will quickly see in our next lecture itself, that while we create the blocks in a blockchain, these types of different combinations of these hashings will indeed be used. In fact, we will talk about construction of what is called a Merkle tree, where we will see that this hierarchical hashing is indeed done. So, overall, if we conclude this lecture, in summary we can say that we have discussed how hash functions are implemented. Specifically, we have talked about SHA-256 implementation, and we also talked about different types of hashing. Indeed, we went to this same web application where we took certain examples, and we saw that we can combine the hashes and the original message in different forms. We can independently do that, we can do them one by one, we can first concatenate, then carry out the hashing, or we can do hashing of the first, concatenate the second one, then do hashing of that, or we could of course carry out the hashings first independently, then we concatenate them, and then do the hashing once again. And of course, as you have noticed that we will always work on these 256-bit outputs of the hash functions. It was only for ease of representation that these 8 bits are used, but you should never ever assume that the hash functions are generating these 8 hexadecimal digits as the output. This is very important. I am repeating this so that there is no confusion at all about generating of the hashes. So, for all of these examples, remember that these are only showing the first 8 hexadecimal digits. Indeed, these are all 256-bit long hashes, and for trying out using this same web application, you can always try it with 256-bit hashes, just as that we cannot represent that in these PowerPoint slides or in a textbook. In the pages of it, we are always showing some first 8 hexadecimal digits for the sake of brevity, as I have already mentioned. So, that is what you need to try out, and of course, you can also think whether indeed there is other ways of combining them, and also as you can see, it is only for 2 different such components of message that we considered for showing these examples. Suppose there are 3, So, you can have mix and match of these combined hashing and sequential hashing and hierarchical hashing for carrying out these different types of hashing for those 3 or more types of messages when they are taken together for hashing. And as I mentioned that in the very next lecture we will talk about construction of Merkle tree, again a backbone of constructing blockchain, specifically Bitcoin, where these concepts of hierarchical hashing will be used. So, that is what is the outlook for our next lecture, and with that we conclude this particular lecture. And once again, these are the references which are also mentioned in the last lecture, and you may go through this first reference, which is very easy to read, and it is a non-technical introduction, although it is a technical topic, but it is a very gentle introduction to this topic and it is very helpful. And when you are going into more details, maths of hash functions and of course, the other topics that we will cover, the second book is a very popular book which can also be used. So, these are the 2 references, and with that we come to the end of this lecture on basic cryptographic primitives. Thank you very much.